Given for x lies between 0 and pi by 2 in the interval of 0 to pi by 2, we need to arrange the order of the functions tan x, x and sin x. So let us consider y is equal to tan x, y is equal to x and y is equal to sin x. Let us solve this by just graphically. Let's take the graph. In the interval 0 to pi by 2 on the domain, and tan x graph we can say tan pi by 4 is 1 and tan pi by 2 is not defined. We can see the graph. This is how the graph goes. Tan in 0 to pi by 2. This is y is equal to tan x and y is equal to x is a straight line which makes 45 degrees. Say this is y is equal to x. And now sin x graph, we can check the graph of sin x. Sin 0 0, sin pi by 4 is 1 upon root 2. 1 upon root 2 is some decimal value and sin pi by 2 value is 1. So we can see that the graph, so this is the graph of sin x in 0 to pi by 2, and clearly from graph we can say tan x is greater than x, x is greater than sin x, or we can say sin x is smaller than x and x is smaller than tan x. So by graph we can say x is small, sin x is smaller than x is less than tan x, so which is none of this. We can go with an option D. Or in case by using the differentiation, we can solve by considering two functions. Let f of x is equal to let f of x is equal to tan x minus x. So on differentiating, f dash of x is equal to secant square x minus 1, and we know that secant square x is always greater than 1. So secant square x minus 1 is always greater than or equals to 0. So which implies that since the function f dash is derivative, so f is increasing, so tan x minus x is greater than 0. So we can say tan x is greater than x. And also now let us consider another function. Let g of x is equal to x minus sin x. So differentiating, g dash of x is equal to 1 minus cos x, and 1 minus cos x is always greater than 0. So which implies that 1 minus cos x is greater than 0, which implies g is increasing function. G is increasing function, so which implies that x minus sin x is positive, that is x is greater than sin x. So tan x is greater than x and x is greater than sin x from 1 and 2. From 1 and 2 we can write tan x is greater than x and x is greater than sin x, or sin x is smaller than x and x is smaller than tan x. So there is no option among A, B, C. So option D, none of this. We need to find the interval in which the function 2x power 3 plus 15, let us consider to be f of x, increases less rapidly than the function 9x square minus 12x, that let us consider g of x. So f of x is equal to 2x power 3 plus 15 and g of x is equal to 9x square minus 12x. So differentiating with respect to x, we get f dash of x is equal to 6x square, and here g dash of x is equal to 18x minus 12, and 6x square is always greater than 0, so we can say f dash of x is greater than or equal to 0 for any x belongs to R, and here g dash of x is greater than 0 for 18x minus 12 is greater than 0, that is x is greater than 12 upon 18, that is 6 2s are 6 3s are, so x is greater than 2 by 3. So we can consider for x is greater than 2 by 3, both the functions f of x and g of x increases. And also given f of x increases less rapidly than the function g of x, means which implies that g of x minus f of x is positive. So let us consider f of x is equal to g of x minus f of x, that is 9x square minus 12x minus of 2x cube plus 15. So that is 9x square minus 12x minus 2x power 3 minus 15. So let us differentiate. F dash of x is equal to 18x minus 12 minus 6x square, and now f dash of x is greater than 0, so which implies that 6 taken common, 3x minus 2 minus x square is greater than 0, or we can write x square minus 3x plus 2 is less than 0, that is x minus 1 into x minus 2 is less than 0. So we can consider the interval 1 to 2. So the solution lies between 1 and 2. So for x belongs to 1 comma 2, for x belongs to 1 comma 2, we can say the function f of x increases less rapidly than g of x. So we can go with an option B. Given the fuel charges for running a train are proportional to the square of the speed. So let us consider the cost as a C is proportional to square of the speed. So let us consider S square here. That is C is proportional to S square. So we can write C is equal to some proportionality constant into S square. To find the proportionality constant, let us assume that it costs 48 per hour. So 48 is equal to K into, and for 16 miles per hour it is, so 16 square. So we can say K is equal to 48 upon 16 into 16. So 16 3 times 48, so K is equal to 3 upon 16. So we can write the cost of the fuel charges as C is equal to 3 upon 16 into S square. And now the total cost including the maintenance charges. So we can write total cost C, capital C, let us consider, is equal to 3 upon 16 into S square plus 300 is a fixed charge per hour and into the total time, and we know that speed is equal to distance upon time. So time is equal to distance upon speed. So let us assume that the distance to be x upon s. So we can write here into x upon s. So we can write C is equal to 3 upon 16 into s into x plus 300 upon s into x. Now we need to we need to minimize the cost. So let us consider differentiating dc by ds, which is equal to 3 upon 16x, and differentiating s is 1 plus 300x into differentiation of 1 upon s is minus 1 by s square, and for minimum we have to consider equal to 0. So that is dc by ds is equal to 3 upon 16x minus 300x upon s square, or even if you go double differentiation, d square c by ds square is equal to, and here we can write minus 300 by 300x into minus 3 upon s power 3, minus 2 into s square, no? So here we can write 600 x upon s power 3, which is always positive. And now for minimum cost, dc by ds is equal to 0. So which implies here 3 upon 16 minus 300 upon s square is equal to 0. So 300 upon s square is equal to 3 upon 16. So here 300 times. So s square is equal to 16 into 100, or s is equal to 4 into 10, 40. So to get the minimum cost, we need to maintain the speed as 40 miles per hour. So we can go with an option D, that is 40. So we need to find the equation of all lines having slope 2 which are tangent to the curve y is equal to 1 upon x minus 3 for x is not equals to 3. So differentiating here to get the tangent slope. So dy by dx is equal to minus 1 upon x minus 3 whole square into differentiation of x minus 3 is 1. And we need to find the equation for which having the slope is 2. So let us consider dy by dx is equal to 2. So we can write 2 is equal to negative 1 upon x minus 3 whole square, or we can write x minus 3 whole square is equal to minus 1 upon 2, which is not at all possible. For any real number, for any x belongs to R minus 3, x minus 3 whole square is always greater than x minus 3 whole square is always greater than 0, which is positive. So, but the other side it is negative 1 by 2. So we can consider that there is no equation, no equation as a tangent to the curve with a slope 2. So we can go with an option D, none of this. The given function f of x is equal to x into x minus 2 whole square. We need to find the interval in which it is increasing. So let's differentiate f dash of x is equal to 2 times of x into x minus 2 into differentiation d by dx of x into x minus 2. So we can write f dash of x is equal to 2 times of x into x minus 2 into x into differentiation of x minus 2 is 1, and again plus x minus 2 into differentiation of x is 1. So we can write 2 times of x into x minus 2 into x plus x, that is 2x minus 2. So we can write 2 times 4x times of x minus 1 into x minus 2. For increasing function, we need to consider f dash of x is greater than 0. So we can say 4x into x minus 1 into x minus 2 is greater than 0. Let's find the critical points. So we have 4x, x is equal to 0, and x minus 1, that is x is equal to 1 and x is equal to 2. So we can take 0, 1 and 2, and by taking the wavy curve, so from minus infinity to plus infinity, and here we can say that the curve is positive in the region 0 to 1 and 2 to infinity. So we can go with an option for x belongs to 0 to 1 union 2 to infinity, the curve is increasing. So we can go with an option C, 0 to 1 and 2 to infinity. Given a square x power 4 plus b square y power 4 is equal to c power 4, then the maximum value of xy we need to find. So let us consider the two quantities as, let us consider the arithmetic mean of two quantities. A square x power 4 and b square y power 4, which is equal to a square x power 4 plus b square y power 4 divided by 2. And similarly, the geometric mean of the two quantities we can write under root of a square x power 4 into b square y power 4. So which can be taken as a into b into x square into y square. And we know that arithmetic mean is greater than or equals to geometric mean. So a square x power 4 plus b square y power 4 divided by 2 is greater than or equals to a into b into x square into y square. Or we can write a square, and we know that a square x power 4 plus b square y power 4 is c power 4. So c power 4 upon 2 is greater than or equals to ab into x square y square. And here we can write x c power 4 upon 2 x square y square, or 2ab. 2ab is greater than or equals to x square y square, or we can write x square y square is less than or equals to c power 4 upon 2ab, or xy is less than or equals to under root of c power 4 by 2ab, which is c square upon root 2 into ab, root of 2ab. So the maximum or minimum value, the maximum value of xy can be taken as, since xy is less than or equals to c square upon root of 2ab, so this is the maximum value. So we can go with an option D. Given function f of x is equal to a square minus 1 upon a square plus 1 into x power 3 minus 3x plus 5 is a decreasing function. So that is f dash of x is less than 0 for x in the real number. So that is a square minus 1 upon a square plus 1 into differentiation of x power 3 is 3x square minus 3 is less than 0. Or we can write a square minus 1 upon a square plus 1 into x square minus 1 is less than 0. And since for this function to be negative, let us recall the quadratic expression ax square plus bx plus c is negative will be under the conditions delta should be less than 0 and the coefficient of x square must be negative, so that it will be under x axis. So here the coefficient of x square is a square minus 1 upon a square minus 1 upon a square plus 1 must be less than 0. That is a square minus 1 must be less than 0. So we can write a plus 1 into a minus 1 is less than 0. So we can consider from minus 1 to 1, and by using the wavy curve method, the negative region will be between minus 1 to 1. So a must belongs to minus 1 to 1. And even in the case of other than the condition of ax square plus bx plus c, for this expression to become less than 0, even x square coefficient can be 0 also. So whenever it is 0, so we can say a belongs to -1 to 1 closed interval. So here it is a belongs to -1 to 1 in case of quadratic expression to satisfy the condition. But in case of like even if the coefficient of x square, if it is equal to 0 also, it is negative. So in such case we can include this -1 to +1. So we can go with an option C. So given in the square, diagonal of a square is changing at the rate of 0.5 centimeter per second. So let capital D be the diagonal of a square, and the rate of the diagonal is changing at the rate of 0.5 centimeter, means we can give d into d by dt is equal to 0.5 centimeter per second. It is given. Let s or a be the let a be the side of the square. So we have the diagonal d is equal to root 2 into a, and if a is capital A is the area, then area of the square is equal to a square. So since d is equal to root 2 into a, so d capital D by dt is equal to root 2 into dA by dt. So it is given 0.1, 0.5, that is 1 by 2 is equal to root 2 into dA by dt. So from here dA by dt is equal to 1 by 2 root 2. So we can write, so dA by dt is equal to 1 by 2 root 2, and now the area is equal to a square, and differentiating dA by dt is equal to 2 into a into dA by dt. We need to find the rate of change of area dA by dt when the area is 400. So when area is 400, we can write a square is equal to 400. So a is equal to 20. So dA by dt is equal to, at a is equal to 20. So we can write 2 into 20 into, and dA by dt is 1 by 2 root 2. So here we can write 20 upon root 2. So rationalization, root 2 into root 2. So we can write 20 upon 2 root 2. So 10 root 2. So rate of change of area when area is 400 square centimeter can be taken as 10 root 2, which is option 10 root 2 centimeter square per second. So which is option B. If the normal to the curve y is equal to f of x, at the point 3 comma 4, say this is a tangent and normal is perpendicular to the tangent, which makes an angle 3 pi by 4 with the positive direction of x axis. Then what is f dash of 3? So let's find the slope of the tangent. Since given y is equal to f of x, dy by dx is equal to f dash of x, and now at 3 comma 4 point we can write slope of the tangent, is equal to dy by dx at x is equal to 3, which is equal to f dash of 3. Therefore which implies normal to the curve can be taken -1 by f dash of 3, and it is also given the slope of this normal, which makes an angle 3 pi by 4. So we can write slope of normal which is equal to tangent of 3 pi by 4. that is tan pi minus pi by 4, which is equal to minus tan pi by 4, which is negative 1. So slope of normal is minus 1. So we can write minus 1 by f dash of 3 is equal to minus 1. So which implies f dash of 3 is equal to 1 by cross multiplication. So we can go with an option D. F dash of 3 is equal to 1. Given function f of x is equal to sin x minus kx minus c, where k and c are constants, and this function decreases always. So that is f dash of x is less than 0. So differentiating, we get differentiation of sin x is cos x minus differentiation of kx is k is less than 0. And we know the range of cos x is minus 1 to plus 1. And we can say cos x minus 1 is less than or equals to 0. And cos x plus 1 is greater than or equals to 0. So for cos x minus k should be less than 0. For this to happen, k must be greater than or equals to 1. So if k is greater than or equals to 1, we can say cos x minus k is less than 0. So we can go with an option B. So option B is the answer. Given function f of x is equal to sin power 4x plus cos power 4x, and we need to find the minimum value of this function in the interval 0 to pi by 2. Means for x lies between 0 and pi by 2, we need to find the minimum value. So let's differentiate. F dash of x is equal to 4 into sin power 3x into differentiation of sin x is cos x plus 4 into cos power 3x into differentiation of cos x is minus sin x. So we can take 4 sin x cos x common, and hence we can write sin square x minus cos square x. So here we can write 2 into 2 sin x cos x, and sin square theta minus cos square theta is minus cos 2a. So minus cos 2x, and here we can write 2 sin x cos x is sin 2x. So minus here cos 2x, and again minus 2 sin theta cos theta is nothing but minus sin 2 times of 2x, that is 4x. So f dash of x is equal to negative sin 4x. For minima or maxima, f dash of x is equal to 0. So we can write sin 4x is equal to 0. So sin theta is 0, that is 4x is equal to, it is possible for 0 or for pi, or we can go with the 2 pi. Then it implies x is equal to 0, pi by 4, and 2 pi upon 4 is pi by 2. And now f double dash, or we can see f dash of x is equal to negative sin 4x, and in the interval 0 to pi by 2 we can assume that pi by 4. So f dash of pi by 4, or let us find first whether it is a minima or maximum at this point. So f double dash of x is equal to minus cos 4x into 4, and f double dash of pi by 4, which gives minus cos 4 into pi by 4 into 4, and cos pi value is negative 1, so negative of negative plus 1, so 1 into 4 is 4, which is positive. So therefore we can say x is equal to pi by 4, f has a minimum, and that minimum value is, f of pi by 4, which is sin power 4 pi by 4 plus cos power 4 pi by 4, that is sin power 4 pi by 4 is 1 by root 2 whole power 4 plus again 1 by root 2 whole power 4, that is 1 by 4 plus 1 by 4, that is 2 upon 4 is 1 by 2. So 1 by 2 is the answer, which is option A. Given the curve y minus e to the power of xy plus x is equal to 0 has a vertical tangent. Vertical tangent means y-axis, slope of y-axis is not defined, that is dy by dx is not defined. So which implies dx upon dy is equal to 0. So we may consider the case dx upon dy is equal to 0. So let's differentiate with respect to 2x. So we can write dy by dx minus e to the power of xy into differentiation of xy is x into dy by dx plus y plus 1 is equal to 0, or dy by dx taken common here, 1 minus x into e to the power of xy minus y into e to the power of xy plus 1 is equal to 0, or dy by dx times 1 minus x into e power xy is equal to y into e to the power of xy minus 1, or dy by dx is equal to, or we can write dx by dy is equal to 1 minus x into e to the power of xy upon y into e to the power of xy minus 1. So for vertical tangent, dx upon dy is equal to 0. So we consider dx upon dy is 0. So we may write 1 minus x into e to the power of xy upon y into e to the power of xy minus 1, which is equal to 0, which implies 1 minus x into e to the power of xy is equal to 0. That is 1 minus x into e power xy we can write from here, e power xy is equal to x plus y. So we can write into x plus y is equal to 0, or we can write 1 minus x square minus xy is equal to 0, or we can write x square plus xy is equal to 1, or x times of x plus y is equal to 1. And clearly we can see that for y is equal to, it satisfies the point when x is equal to 0 comma 1 does not satisfy, 1 comma 1 is not satisfying, 0 comma 1 does not satisfy, and 1 comma 0 when x is equal to 1 and y is equal to 0 it is satisfying. So 1 comma 0 satisfies the equation x into x plus y is equal to 1. So we can go with an option C. So 1 comma 0, at 1 comma 0 we can see it is having vertical tangent, that is dx by dy is equal to 0. So we need to find the number of points of either local maxima or local minima for the given function f of x is equal to 2x to the power of 3 minus 3x square minus 12x plus 4. So to get local minima or local maxima we need to find differentiation and put equal to 0. So differentiate f dash of x is equal to 6x square minus 6x minus 12. So we can take 6 common, x square minus x minus 2. So we can write 6 times of x minus 1 into, or x minus 2 into x minus 1, we can do factorization, or x plus 1. So minus 2x plus x minus 2. And now f dash of x is equal to 0 for minima or maximum. So we can say 6 times of x minus 2 into x plus 1 is equal to 0, which implies either x minus 2 is equal to 0 or x plus 1 is equal to 0. That is x is equal to 2 or x is equal to minus 1. Now let us identify whether for x is equal to 2 is minima or maximum. For this double differentiation, f double dash of x is equal to 6 times of differentiation of x square is 2x minus 1. So 6 times of 2x minus 1. Now substitute f double dash of 2 is equal to 6 times of 2 into 2 minus 1, that is 6 times of 4 minus 1 is 3. 6 3s are 18, which is positive. So at x is equal to 2 we have minimum. So f of x has local minimum at x is equal to 2. And similarly now at x is equal to minus 1, f double dash of minus 1 is equal to 6 times of 2 into minus 1, that is 6 times of minus 2 minus 1 is minus 3, which is negative 18, which is less than 0. So he can say f of x has local maxima at x is equal to minus 1. So we can say one point is local minima, one point is local maxima. So one maxima and one minima, which is option C. Given a circular plate is heated uniformly, its area expands. Area of circular plate will be pi r square. If A, capital A is the area and r is the radius, and it expands 3c times as fast as its radius. So given that dA by dt is equal to 3c times dr by dt. Since we know the area of circle is pi r square, so differentiating dA by dt is equal to pi into 2r into dr by dt. So here in this case we can write 2 pi r into dr by dt is equal to 3c into dr by dt. So we can say dr by dt we can cancel, and we can write here r is equal to 3c upon 2 pi. And now let us consider when r is equal to 6 units, 6 is equal to 3c upon 2 pi, or we can write 3c is equal to 12 pi, or c is equal to 12 pi upon 3, which is equal to 4 pi. So the value of c is 4 pi units. 4 pi you can consider when the radius is 6 units according to the condition. So we can go with an option A. The given function f of x is equal to tan x minus 4x. We need to identify in which interval it is strictly decreasing. That is f dash of x is less than 0. So differentiating tan x is secant square x minus 4 is less than 0. That is secant x plus 2 into secant x minus 2 is less than 0. So secant x must belongs to minus 2 to plus 2. So let us check the interval. Since we know that the range of secant x is minus infinity to minus 1 union 1 to infinity. So let us consider the interval for x lies between minus pi by 3 and plus pi by 3. Secant x will lies between, because secant of minus pi by 3 is also positive 2, so it lies between minimum is 1 and up to 2. So secant square x lies between 1 and 4, and secant square x minus 4 is lies between minus 3 and 2. That is f dash of x is negative. So we can go with an option minus pi by 3 to plus pi by 3, f dash of x is negative. Option A can be the answer. Or if we can check the option B, for x lies between pi by 3 and pi by 2, cos 90 is 0, it is not defined. So secant x lies between 2 and infinity, and secant square x lies between 4 and infinity, and secant square x minus 4 is lies between 0 and infinity, which is positive. So we cannot go with an option B. Similarly option C and option D can try. So option A is the answer anyhow.